You're going to be asked to memorize the sine, cosine, and tangent of 30, 45, and 60. And you studied these triangles in geometry, these special right triangles, and the relationship of their side lengths. So if you remember in a 30, 60, 90, it looked like this. We called this the short leg. Okay, where the x is the short leg of the right triangle. The hypotenuse was always twice whatever the short leg is. So if we represent the short leg with x, the hypotenuse is always twice the length of the short leg. So that's why it's 2x. And then the long leg, so we call this one the long leg, was represented as whatever the short leg x is, because that was x times square root 3 in exact form. In a 45, 45, 90 triangle, okay, if you think about these two angles being the same, and you studied a lot of this in geometry, then these two legs are the same, and we represent those with x. The hypotenuse was whatever the length of a leg was, x, multiplied by square root 2. And that can be derived from the Pythagorean theorem as well. Okay, so if you look at those relationships, if I said, what's the sine of 30? Well, if you remember, sine of 30, if we look at this 30-degree angle, sine is opposite over hypotenuse. Well, opposite would be x over hypotenuse, which is 2x. And if you think about what that means, that's 1x over 2x, so it would be 1/2. The sine is equal to, of 30 is 1/2. Okay? The cosine of 30, so if I think about, because this was my opposite side, this would be adjacent to the 30-degree angle. So the cosine would be x is adjacent over hypotenuse. Adjacent means next to. So it would be x square root 3. That would be my general length of my adjacent side over the hypotenuse, 2x. Well, the x's cancel again because it's multiplication, and it is square root 3 over 2 in exact form. So the cosine of 30 is square root 3 over 2. The tangent of 30 would be opposite over adjacent. So if I did opposite over adjacent, here's my 30. This would be the opposite side. X over the adjacent, which is x square root 3. Now, if you remember right, the x's cancel, so it's 1 over square root 3. Can't leave a square root on the bottom, so we rationalize just like we did last quarter. So it's square root 3 over 3. Square root 3 times square root 3 on the bottom is that. Okay? So 1/2 square root 3 over 2, and then square root 3 over 3. And while we're in the 30, 60, 90 triangle, let's go over to the sine of 60. If I go to the 60-degree angle, okay, so now I'm looking at this angle right here. Sine is opposite over hypotenuse, so opposite would be x square root 3 over hypotenuse 2x. X's cancel, so the sine of 60 is square root 3 over 2 in exact form. Cosine would be adjacent over hypotenuse, so if I'm at this 60-degree angle, again right here, the adjacent would be x over hypotenuse 2x. Well, that's 1x over 2x, x's cancel, so it's 1/2. So the cosine of 60 is 1/2. And the tangent of 60 would be opposite over adjacent. So if I'm at the 60-degree angle, opposite would be x square root 3 over the adjacent, which would be x. X's cancel. Now this one, the square root's on the top, or the radical, so it's square root 3. So the tangent of 60 is square root 3. If you look at the 45, 45, 90 triangle, so now we're looking at this triangle. Definitions of these trig functions don't change. So the sine of 45, let's go from this angle, opposite over hypotenuse, so it's x over x square root 2. X's cancel, so it's 1 over square root 2. But we got to multiply top and bottom by square root 2. So it's square root 2 over 2 is the sine of 45. Cosine is adjacent over hypotenuse, and both the opposite and adjacent, no matter which 45 you're at, are the same. So it's x over square root 2, okay, or x over x square root 2. And again, it's going to be the same when I get rid of the square root 2 and cancel my x's, square root 2 over 2. So both the sine of 45 and the cosine of 45 is square root 2 over 2. Tangent would be opposite over adjacent. Well, if I'm opposite, that would be x over the adjacent x. That's 1x over 1x. X's cancel, so the tangent of 45 is 1. Okay, now why are we going through all this? So basically, if you look at this table right down here, and it also goes into the other trig functions, the three new ones, those are all going to be things in the unit circle in the next section when you get to the coordinates and the tangents of the spots on the unit circle. So it's very important that we start to think of those and remember some of these exact values of these different functions, of these different trig functions.